Okay, I'm back, and in this video we're gonna review all the derivative rules of trigonometry functions and also as well the inverse trigonometry functions, and I'll derive some of them as well. So now let's look at the derivative rules of the sign of something, right? The sign of something. Remember, something can be a constant, a variable, expression, like function. So, and Venus, you know, that is just the cosine of something, right? The cosine of something. And the derivative of cosine of something, it's the sine of something, but it's negative. And you know what, I just talk about the trig right now. So when you're taking all the derivative of trigonometry functions or inverse trig functions, if you're taking the derivative of any trig function or inverse trig function, or actually let's talk about trig function first. Any trig functions, and that trig function start with a c. If you're taking the derivative of any trig function that start with a c, okay, the result is going to be negative. So all the c, just remember, all the c give you negative. All the c trig function give you negative if you take the derivative of it. So next we're going to talk about the derivative of tangent something, the tangent of something, which is what? Right, secant square something. And just a side note here, secant square of something, here's another way to write it, is the secant something. You're squaring the secant something, so be careful. You're squaring the whole entire ratio here. Okay, so next, the derivative of cotangent of something is equal what? Yes, it's equal to the cosecant square something. But remember, I said earlier, if you're taking the derivative of any trig function that start with a c, then the result will be negative. You'll have a negative sign there. So, yep. So next will be the derivative of secant something. What is that? That's just secant of something and times tangent of something, right? And remember, not negative, because secant does not start with a c, so there's no negative sign in front of there. So next, I think this is the last one for this trig function. Alright, the derivative of cosecant of something would just be what? Oh wait. Okay, sorry about that. Not supposed to be there. Okay, cosecant of something is cosecant something times what? Cotangent something, right? Oops, sorry. Okay, and remember the last thing, it has a minus sign in front of it because cosecant start with a c. Next, let's talk about the inverse trig function. Okay, let's talk about all the. Oh wait, you know what? Okay, let's derive some. Let's derive some of the function that we done before. Like, as you remember, the derivative of tangent something, it's secant square something, right? And how do we know if we don't remember this? We don't have to memorize this. We can derive this from the sine and cosine, the derivative of sine and cosine. What happened is, remember, tangent can be written into a form of sine something over cosine something, right? So whenever you're taking the derivative of a tangent something, it's the same as you're taking the derivative of sine something over cosine something. And what happened is, so if you want to take the derivative of this one, you have to use the quotient rule, right? So now let's do it. Okay, we can do it on the same page actually. So remember the quotient rules as this. Oops. Okay, it's f times g prime over g square. Okay, so if you use that, it will be cosine something times the derivative of sine something, which is cosine something, right? Cosine of something, and then you minus sine something, and the derivative of cosine something, it's minus sine something, right? So this minus sine something, and everything will be over cosine square something. Okay, now we just compute this, and to do that, I'm gonna make a new one here. I hope I can make a new one. I'm trying to make a new page, but this guy is just not helping. Okay, I'm gonna just erase some of them. So if you compute that, the whole thing, it would just be cosine square u minus, right, at sine square u over cosine square u, right? And at this step, you have to remember that cosine square u plus sine square u is equal 1 according to those what was that called? The trig identity? Yeah, Pythagorean theorem identity. Okay, so if this portion is equal 1, then that means the entire thing is just 1 over cosine square u, right? Or something, cosine square something. And remember that this one can be also writing in this way. So that's why the derivative of tangent x, or tangent to something, it's secant square something. Yep. We can also prove another one. Every one of them can be derived. Like, remember, if you take in the derivative of cotangent of something, remember cotangent can be written in sine and cosine as well, and that will be just what? Cosine of something over sine of something. And then you use the quotient rule again to find a derivative of this and compute that, and then at the end you will get 1 over sine square something, which will be cosecant square something. And now let's derive another one, which will be, let's derive this secant, right? Secant something. And remember, secant can be written in what? In the form of sine and cosine, but you can write it as 1 over cosine, right, of something. So just use a quotient rule on this one. And now you know, if you use the quotient rule on this one, it will be cosine u times derivative of 1 is 0 minus 1 times, it will be minus sine u, right? That's the derivative of cosine u, or cosine something. And then at the bottom, it will be cosine square of something. So what you have here is minus, but since there's a minus sine something, and you have cosine square something, right? Remember this. We're gonna do this on a new page because I ran out of space. So this is just negative sign here, minus negative sine of something. So which means it would just become a positive sine of something over cosine square something. Now you remember, the derivative of secant of something is what? It's secant of something and tangent of something, right? Tangent of something. You think like, okay, why is that? Because we got this answer, not this. But the trick is to rewrite it as sine of something over the cosine of something times 1 over cosine of something. Because remember, like, this is a product, right? So you can separate the product and there will be no problem. So because even if you multiply this two fraction back together, it will give you this fraction. So yep, I'm not gonna say too much, but you can check it. So now you know sine something over cosine something, that's just tangent of something. And 1 over cosine of something, yep, that's secant of something. So that's how you derive it. And the concept of taking the derivative of the cosecant is the same thing. You just use the quotient rule. First, okay, you know what? Let's write it in a paper. Okay, first you will write everything in terms of sine and cosine. Of sine and cosine Oops. And then the second, you would just use the quotient rule. To find the derivative. And third one, we write or some people call that simplify. Yep, so that's how you derive all the trig function, or the derivative of the trig function other than sine and cosine.